Hello everyone, good morning. So this is the quiz that we taking, okay, last week. So average is 38 or 59, so it was really low, and this is actually a typical question in the textbook. I'm only taking typical question, so it's considered really low. So you need to do better next time. Okay. So I would like to discuss how to solve all these questions. Okay. Uh, okay. So especially number two. Especially number two. I think only. I think. I think no one solved number two. I think two students getting close to the complete answer, but it's not complete yet. So I will start from number one. Okay, number one, test the following series for convergence or divergence. Okay, so I think I had give you like a lot of testing, right? Some questions. You can check the Moodle, the notes, or the videos, and also DA give you something, right? So from all this, you need to have some strategy. Okay? You need to have some strategy. As I mentioned, if you have this -1 like this, okay, definitely try the alternate series directly. Okay? Try the alternate series. What alternate series? The requirement first, you need to know that it will always decreasing. Okay, for over the time it will always decreasing. You can check from n equal 1, which is 0, and n equal 2 is ln 2 over square root of 2, and then ln 3 is ln 3 and the square root of 3, and you can imagine what it looks like, okay, if we add another terms. Okay. So you could check the terms. Even you can use calculator, right? You can use calculator, check the terms to check whether it's decreasing. Okay. So you know that it's decreasing. Okay. And second, you take the limit. And of course, if you are not know how to take this limit, then this cannot be solved. Okay? So you need to know how to take this limit. Okay. Remember in calculus 1, whenever you have a ln, you can take the L'Hopital rule and you check first. You check the limit. Okay, check the limit. You put in here, infinite over infinite. That means you can use L'Hopital. Okay. Use L'Hopital. And then you can cancel this with this. So this is square root of n. So 1 over square root of n will be 0 in limit. So this will be equal to 0, right? So this will be equal to 0. Okay? Got it? So when this decrease is equal to 0, then number 1, A is converge or diverge? Converge, okay? Converge. Okay? And the second one, whenever you find any complex function or the series like this, like it's too complicated down here, what you can do? Comparison test. Okay? No need to think with other methods. It doesn't work. It doesn't work. And you will see that we cannot solve this. We cannot solve it. You can think using ratio test. Any test it will work. Okay? Because this is having cosine. Too complicated. So directly comparison, okay? So I know that most of you are failing calculus before, right? So I want you to have this mindset, okay? It's not like, okay, we solve this from 1, 2, 3. No, but you need to have a good strategy, okay? Good strategy. Like, I think most students, okay, we solve this question, blah, 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 oh, 1, 2, 3, oh, okay. But I want you to have a really sharp, okay, really sharp mindset, and don't be too naive, okay? I hope you understand what that word means, okay? So you can think directly. This is too complex. Whenever you have this too complex in this downwards here, it means that maybe you can compare this to something, okay? And remember, I also write in the class. I write in class like the cosine is this, and we have the squared, so it means when we have the squared, it is between the 0 and 1, right? It's between 0 and 1. And what does that mean? What does that mean? It means that the maximum is only 1. Okay, so if we have this, cosine squared, maximum is only 1. So it should be less. Okay, it should be less. At least less than equal this, right? Okay. So you can think like cosine, the number is between 0 and 1. It's between 0 and 1. Oh, wait, not less, sorry, should be this, right? Okay, should be this. Right. So because 0 and 1, for example, it has maybe half, maybe 1 over 4. So 1 over 4 is, let's say it's 1 over 2. 1 over 2, n plus n is 3 over 2, so it's 1.5, and you see it's greater, right? And this one is harmonic series, okay? So if we take this from 1 to infinity, this is going to diverge, right? Okay? And for comparison test, if you don't know the value or the estimation for the one that you want to compare, then I don't think any series will work. Okay? So first you need to know this one is diverged because it's harmonic series. Okay? So, or you could think you could use the 1 over n with power of p. So p less equal 1 is diverge. P greater 1 is converge. I think I said it many times. So use this. Okay, use this. And this is the one series that easily to be compared. Okay. So since it's diverged, okay, and this is bigger than this should be diverged. Okay. So this will be diverge by comparison test. This is by alternating series. Okay. Now the third one, the number C. We have something n with power of 2n. We have 1 plus 2n squared and power with 2n. Right? Okay. Notice that we have power n automatically should be directed to the root test. Okay? If you don't know the root test, it is actually taking the square root with n like that. So this will be n to n. So 1 plus 2n squared power of n. So we have n squared and over 1 plus 2n squared. Okay. Okay, and then we take limit. We take limit this. So this is 1, this is 2, this is 0, right? So 1 over 2. Okay?
So this is taking limit of n so this will be 1 over 2. And what is the conclusion for the root test? Okay, so root test, if this is less than 1, it's converge. If greater 1 is diverge. What about equal 1? No conclusion.
This result the same with ratio test, which you are going to use in number 3. Okay? How about number 2? Number 2, the way we are going to work this out is looking at how the factors goes, and you need to think which Maclaurin function it will be. Which one? Okay. So this one needs to be, you need to arrange or identify Maclaurin. Okay. Several Maclaurin that I expect students need to know is e to the x, 1 over 1 minus x, sine x, cosine x, tan inverse x, ln 1 plus x. Okay, I think I give you the table, right? And then I know like sometimes students maybe forget. Go back to the Maclaurin definition, which we are going to use this. Okay. This is the definition of Maclaurin, which means if we are not knowing what is this, maybe we could trace this. So there are, I think, 2 ways to solve it. First, from the series, the expansion, we can write the formula for the series. Okay. Or we could start thinking what kind of Maclaurin that can be implemented and can be applied. Okay. Notice that you have 1 minus e, and you can see that under the is actually 1 factorial, but 1 factorial is just 1, right? So I think if I write this, you see that we have, if I write this, we can have n factorial, n factorial, n factorial, right? N factorial. But this is 1, so perhaps this is going to be this, just power with 0, right? Power with 0. So we need to think what is the component. And the top, if you see e, and maybe if you just imagine that like x, okay? If this is x, so x squared, x cubed, x4, which means that is the component here, okay? Which means if you have a function that has a variable x, to get into this, you change the x into e. You get it? Okay? So what we are going to do is we are either finding the series from here, we find how it will be. So from here, find what kind of series, or check several functions that you know. Maybe the simplest one. The simplest one is 1 over 1 minus x and e to the x. Okay. If you choose 1 over 1 minus x,
This is this. Just x to the power of n.
No factorial on here, right? If you choose this function.
And remember, we also have the e, right? And I suggest to study this e.
What is the series for e?
Anyone remember? Sum of.
Anyone remember? And what if you forgot? What will you do? Is this. Okay. Now, before we write CE, what is the derivative of E? E to the x. What is the derivative of E to the x? The same, right? The same, okay? The same. If you put 0, what will happen? 1. So if you derive, you put 0, you put 0 again for the second, third, fourth derivative. Is it the same? Same, it's 1, right? So it's 1. Okay? Okay? Get it? And then this n factorial, x to the n. Easy, right? You get x to the n over n factorial. That's it. That's for the function of the e to the x.
Okay?
Do you get my idea? Do you get how we get this? Okay?
I think you still not get it, right? So you took f0, okay? So this will be e0, this will be 1. You put this first derivative, you put the same functions, right? And it's just 1. You put another 1, and you get another 1, right? So then, if you check within the series, you first write f0 is 1, okay, plus the f10 is 1 over 1 factorial x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. This is the way you do Maclaurin.
Okay, this is the way you do Maclaurin. And then this, you can make a series that's okay. But this should be start from 0. Sorry. It should be start from 0.
Okay.
And now, do you think they're similar? Similar, right? 1 factorial, 2 factorial, 3 factorial. We change this x with e, right? X squared, e squared, right? X cubed, e cubed. The same, right? Okay, the same.
So if we have, so this is e to the x. So if we have e to the e, this will be e1 plus let me just write x plus x squared but we still have something missing.
We have minus, plus, right?
So that is the alternating. So every alternating. So alternating means we have component of -1. Okay. Either it's going to be n or n minus 1, right? But in our case,
Since it's changing only e and then e cubed, 5, 7, the odd number, right? So where is the odd number here, right? On the variable x. So if we take negative,
so if we take this, so if this change with -e, what will happen? Oh, why I'm writing x should be e. Sorry. Same, right? Is it the same as that's the question?
So the answer is this. Okay.
So this will be the answer. So sum of the series okay.
So the way you work, you can start from here or start from taking the series, take into the sum, and then from the sum you could get the what kind of functions that you can identify. I think most students, they get it to make it the sum, but they seem confused what they should do from the sum. So the idea, every time you have find the sum of the series, it should be about representation of the functions. So you need to represent the series in a function so that you can simplify the whole series, become a one single function that can be interpreted using either Maclaurin series or just a usually the 1/1 minus x. It could be from it could be defined in other function as well. Okay. And remember, you can derive, you can integrate. Okay, that's another variation. So sometimes you get this, but this is the form of the after you integrate. So maybe you need to derive, or maybe you need to integrate. It can be done that way. Okay. Okay, that's number 2. So the more you take some practice, the more you can easily identify. Okay. So if you don't take some practice and maybe hoping that the question is just as simple as the one that maybe we showed previously, I don't think that will be work. Okay. So you need to take practice by your own. Try your best. Okay. Identify the series and functions. Okay. Number 3, I think most students did very well, but I believe you need to also work very hard for this one. And I hope this is this type of question that should be handled very clear. Okay. So whenever you get a question about convergences, interval, radius, the first thing is finding the ratio. Okay, finding the ratio. Okay.
So finding ratio means this means you need to take finding that. Okay. So since it's a fraction, then first we take 2 with power of n plus 1, and then x minus 3, and then n plus 1 again, and then over square root n become n plus 1, so n plus 4, okay, in absolute value, and then multiply with and then switch the square root n plus 3, okay, and then please write carefully because this is something that you need to be getting full points. Okay, expected to be full points. Okay. Okay, now we can cancel this one and then this one, and then this will be x minus 3 left, and then cancel this, so you have 2. Okay, most students forget the 2. Okay, okay, this is absolute value, and then this equal x minus, so 2 x minus 3, or maybe let me write with the absolute value, and then multiply with this square root. Let me write here. Okay. Square root, or maybe let me write square root, pick one, n plus 3 over n plus 4.
If we take limit of this n, because they have same degree, so they can be cancelled. So this is 1, right? This is 1. Anyone still confused why this is 1? Raise your hand. I would like to know. So take this limit. This is 1, okay? This is 1.
Okay, so to take limit, so or you can write as n approach infinity. Wait. Okay, as n approach infinity, this one approach 1. Okay, so we have only this. Okay, so the 2x minus 3, okay, to be converged, this need to be less than 1, okay, to be converged. Why? This is the same reason with the root test. Okay? So ratio test need to be, the value need to be less 1 to be converged. Okay, so the radius is half. Okay, so this is radius of convergence. Then we start from this. Okay, maybe I will erase this part first. Okay, now we solve x minus 3. Okay, so we have x, this is 7 over 2, this is 5 over 2. Okay, so it seems that this is the interval of convergence, but we need to check. Okay, check the endpoint. So check x 5 over 2.
When x 5 over 2 minus 3 is 6 over 2, it will be minus, right? Minus 1 over 2.
So minus 1 over 2 means, so you have 2 power n, and then this will be minus 1 over 2 with power of n. Okay, what we can do, we can cancel, right? We can cancel 2 because it's the same power, right? The same power. So we have, and then we can have alternate series, and then 2 cancel, so it's just square root of n plus 3.
If you see from the alternate series, it's always decreasing, and this one is 0. Okay? So it's converged.
This will be converged by alternating series. And then check 7 over 2. And you will see that 7 over 2 will be equaling to 1 if we minus 3. So 1 over 2 and 2 will be just 1. So we have 1 over square root of n plus 3. Which is, this is going to be what? Diverge. Diverge because of series 1 over x, or maybe n power of p, that p should be 1 diverge. So interval of convergence become, need to include 5 over 2 but exclude the 7 over 2. So this is the interval of convergence. Okay, every radius of convergence and interval of convergence, if it is happening in the midterm, I'm expecting you get the correct answer. Okay? At least the process. If you get the maybe miscalculation, still okay. I still give you mostly the points. Okay? Like you get maybe something wrong here, you get some miscalculations, but the way you process is right. So if you have like full answer is 20, right? But if you get the process, at least 15 to 16 you get. Okay? 15 to 16. So I still give almost full points, okay? If you miscalculation. But if the process is not okay, like the whole thing from the beginning not okay, we're still trying to get it, I still give points, but maybe not too much. Okay? And then number 4 is another Maclaurin. So every time Maclaurin is going to be in the questions, I expect you to know how to get the Maclaurin series. Okay? So the Maclaurin series first is taking the functions, take 0, and then calculate it. Take the derivative, put 0, calculate it. Take another derivative, put 0, calculate it. And then put all of them into the series. Okay? What is the series? The series is this one. Okay? This one. So take n from 0, 1, 2, 3, 4, and so on and so on. So, for example, this one has sine and then x to the power of 4. Okay? So what does that mean is we need to know sine x. It's good if you know before, like maybe you memorize and then you know. Sine x, or since sine x is series of the sum of blah blah blah, then for this one, you need to change, just changing x with x power of 4. Okay? So let me show you. Okay? So suppose that you don't know. Okay? Suppose that you don't know. Okay? Let me erase this for a while. Suppose that we start with sine x. Okay. So f at x equals 0 is 0, and then we have maybe this could be that way. We have first derivative is cosine x. Maybe 5. Okay. This is -1. 4 is 0 and f5 is 1. Okay, now let me write again. What is the Maclaurin? Maclaurin is sum Now start from 0. 0 is 0, so we can write 0, or let me just write like that. 0 plus 1. Okay, 1 over n factorial x to the power of n. Or let me just write x like that. Okay. And then negative or plus, since it's 0, and then negative x3, right? Y is n. Should be 1. Okay, it should be 1. Okay. And then this is 3. And then 4 is 0. And then the other one is positive. And you're going to expect another one is to be -0 and then negative, right? Or we can actually maybe just erase the 0. Okay? Maybe erase the 0. Okay, now we have this. We need to make into our sum. Okay. Now the bottom has a odd number. Odd number is this. Okay, starting from n equals 0. Okay, starting from n equals 0. And this has 2n plus 1, another odd number, right? But we have the alternate series. Okay. So we have this. And that's it, this sine x. So this is sine x. So if we want to make sine and then x power of 4, write the same thing, but change the x with x power of 4. So negative 1n, and then x power of 4, and then multiply with 2n plus 1. And then 2n plus 1 factorial. Or we can write x 8n plus 4 over 2n plus 1 factorial. And this is the sum. Okay. All this is Maclaurin steps. You could skip this if you want. If you know the sine x is this, so you just change the x with x power of 4. Okay. And then if we need to find the radius, right? Find the radius. Associated radius of convergence. So it's simply the same with the number 3, which means this is our series now. We find the ratio from here using an plus 1 over an. Find the ratio and then find the radius of convergence. Okay? So the way we do it is we take the an plus 1 over an. Okay, so x 8n plus 1 plus 4 and 2n plus 1 plus 1 factorial, and multiply x 8n plus 4. Now this will be x 8n plus 12 over 2n plus 3, 2n plus 3 factorial, 2n plus 1 factorial. This is x 8n plus 4. So x 8n we can cancel. So we have x12 and x4, which we can also cancel. So we x with power of 8. Okay. Now 2n plus 3. 2n plus 3. Let me resize this. So 2n, let me write here 2n plus 3 factorial is 2n plus 3, 2n plus 2, 2n plus 1 factorial. Okay, so we can cancel those with that and then adding 2n plus 2. So we have x power 8, and then we take limit 1 over 2n plus 3, 2n plus 2. This limit is 0, right? This limit is 0. So since this limit is 0, so that every x will be possible. So the radius is actually So radius is actually will be infinity.
Because every x is possible. Okay.
Or you can write r is infinity since limit is 0. Okay. Okay, any questions? Which part you still maybe having some
Confused. Okay. Have you checked the last year midterm on the Moodle? Okay. Does your TA give the answer key already? Or not yet? Ready? The answer key from TA?
I have another last year, so it's actually the same but different class. So I think I will show you
how, and maybe tomorrow we can discuss more about that. Okay.
So your midterm
Will be covering chapter 10, 11, and a little bit chapter 12, especially the quadratic surface. But mostly still 11. So 10, maybe 35 or 40%, and then chapter 11, maybe 45, and the rest will be the chapter 12, the quadratic surface.
and then this is your quiz. I have checked all.
You can check on unit.